So, Assalamualaikum warahmatullahi wabarakatuh to Mr. Rizan. My name is Abdul Rashid bin Abdul Rahman. I am from DME 43 Delta and my ILAM ID is 018935. So, I choose gear pump as my final project for the 3D modeling. So, today I am going to show you the video on how I make the gear pump from the beginning with the animation also. Thank you.
So this is my gear pump housing. As you can see, I already colored it red and green. So I will explain how to start from the beginning. Let's go. The first one is post extrude. So choose center point straight rod and make two of the circle with a length of 63.50 millimeter, and we have to cut out the inner circle is 78 millimeter and the outer circle is 122 millimeter. Then when you already use smart dimension to put this length, we both extrude it, so it will become like this. The thickness of this thing is 64.50 millimeter in diameter. 64.50 millimeter. Next, so for the cut extrude, as you can see before this, we have a inner circle and the outer circle. So we cut extrude the inner circle with 52.0 millimeter of that. Okay, from this circle, from this, we cut extrude it. After we both extrude it, so it become like this. So the depth of this inner circle is 52 millimeter. Next, we go to cut extrude 2. So as you can see here, this is the we first must select center line and put between this point and drag this to this point, and then from the middle part we make two circles. The inner circle is 12.5 diameter, 12.5 millimeter diameter, and then the outer circle is 3 millimeter larger than the inside one. Then we both extrude it. The 3 millimeter difference we both extrude it, and the inside one, which is 12.50 diameter of circle, we cut extrude it. So we can get a hole like this. When cut extrude, don't forget to choose cut extrude until the next wall, so the hole will be gone until the next wall. Next, we go to cut extrude 3. Cut extrude 3, we do the same thing, but on the left side. So on the left side, same thing as cut extrude 2. Like this, put center line between this point, and then at the mid part make two circles which has diameter of 16 millimeter, and the outer circle is 3 millimeter larger than the, the inside one. So same thing. Then we cut extrude the inside circle, then we both extrude the outside one like this. The thickness of this both extrude for both sides is 3 millimeter. Next, I'm sorry, the thickness is 6.25 millimeter. Next, Bosch X4. So for Bosch X4, this is the original of the base. We make a circle with a diameter of 50 millimeter and put center line from mid circle to mid center point. From this to this, the length is about 50 millimeter, and then we choose this 3-point arc and use it to place here, here, and here. Select 3 point and both extrude about 3 millimeter. This thing is about 30 millimeter thickness. Then the things become like this, and then move to the next part. Okay, this one, whole one. So we use the, where is it? We use hole wizard. Use hole wizard and select legacy hole. Choose counter board type and set the diameter, depth, seaboard diameter, carbon depth to 10 millimeter, 100 millimeter, 20 millimeter, and 20 millimeter respectively. So use the hole wizard to make this hole. The diameter is about 10 millimeter. Next. Alright, this is another hole. This is the M5 clearer hole 1. Select the hole wizard also. And select simple hole. So then we can select the this is the size M5 size, and change the depth of the screw to 20 millimeter, and the hole is located 47.5 from the center point of straight slot. So from this to this point is 47.5. From this point to center point of the center point straight slot. Then when you do that, just choose this linear pattern and choose circular pattern. So at this point, we choose 180 degree with a 7 hole. 1, 2, 3, 4, 5, 6, 7. Then it will become like this, 180 degree, 7 hole. So this all this size is M5 size and 20 millimeter. Then at about this axis, we mirror the hole and the boss extrude of this with this hole, and it will become like this. 7 hole and 5 millimeter with this thing. Then boss extrude 5. You see what when this in here, we choose select offset entities, choose this, and then click on the line of the side, and then when you select the offset entities, change it to 6.25 millimeter, and then boss extrude to 12.5 millimeter of thickness. 12.5 millimeter of thickness. Okay. Then we cut extrude 6. What happened here is we make two circle diameter of 28 between 2 point diameter. So top circle we cut extrude till base till 63.5 millimeter, and the bottom circle we cut extrude it with 6.25 millimeter of depth. 6.25 millimeter of depth. Okay. This one we're gonna put shaft and pin to hold the gear. And then for the fillet one, choose the outer line of this housing, and then we fillet it. Okay. Okay, for the cut extrude, okay, this side, we choose this line, and select it, then we cut extrude to make a space for the seal. So for the cut extrude, we change it to 2.5 millimeter of this thing to put a seal inside of it. So that's all the explanation about the gear pump housing. This is the isometric view of my gear pump housing. So this is my gear pump casing. Okay, let's look how we done it. So first is Boss Extrude 1. Okay, as you can see here, Boss Extrude 1. To do this thing, you have to choose center point straight slot, and then you draw two center point straight slot. So the center point straight slot, the length, for the center line, you by using smart dimension, we use 63.50 millimeter, and then for the cut out of the outside center point straight slot, we put 122 millimeter for the cut out. And then for the inside center point straight slot, we use 11.5 millimeter of radius for the center point straight slot of the inside one. Okay, then go to features and extruded boss of this center point straight slot, and then it will become like this. So the inside center point straight slot has 11.50 millimeter of radius. Then boss extrude the outside center point straight slot. So then change the thickness. The thickness of this boss extrude one is 12.5 millimeter. Okay, moving to cut extrude 2. So cut extrude 2, let's see. So for cut extrude 2, we're going to cut extrude the inside one. So then extrude cut the inside center point straight slot. So before we while we're doing the cut extrude, don't forget to reverse the direction of the extruded cut, and extruded cut the inside with 6.25 millimeter of that. So the depth of this extruded cut is 6.25 millimeter of depth. Alright, then we go to fillet one. So at here, we choose this line, these edges, and then we fillet it. We fillet it like this with choose line or edges and fillet it to 3.75 millimeter. The fillet. Then, alright, for the fillet 2, let's go to the other side. Okay, select this line or edges of the center point straight slot and fillet it to 1.75 millimeter. After we done this, choose this surface. Okay, choose that surface. Okay, as you can see here, choose this surface, and then hole wizard. We choose this surface, hole wizard, choose hole legacy, select counter board type. Okay, select counter board type and change the diameter to 5 millimeter.
M5 5mm, change the depth to 100mm, change the counterbore diameter to 9mm, change the counterbore diameter to 5mm, and use smart dimension to place circle which is 47.5mm from the center of the point straight slot. So from this point to here is 47.5mm away from the center point straight slot. Okay, when we already done one hole, we use right top plane, and we choose 180 degree for the circular pattern, and change the number to 7 number of hole within equal spacing. So 1 2 3 4 5 6 7, 7 number of hole with equal spacing 180 degree. Then choose top plane, we mirror it, so the bottom side of the casing will have the same size of hole as at the top of the casing. So 1 2 3 4 5 6 7. So this is all for the casing part. So the last one is this is the isometric view of the casing of the gear pump. Thank you. So this is our third part, which is a gear pump connector that connect gear shaft and gear pin. So I will explain to you how we get done this thing. So first we go to Boss Extrude 1. Alright, let's see. So as you can see here, firstly we must choose center point straight slot. Okay, and then when we do the center point straight slot, we take circle, and then from this point we make 2 circle for the top and the bottom one. So, and then the length for the center point straight slot is 63.5mm. And then when you want to have both of the circle from bottom to top same size, you just click on it and make sure it is equal. Then you use smart dimension. The inside one is 16.25mm of diameter, and then the outer circle is 11.5mm. Okay, so after we already put the dimension of the connector, we both extrude it. Okay, like this you can see. Let's exit sketch. Okay, the thickness of this extruded boss is 3.125mm. So if you want to extrude it, let's see, edit sketch. Alright, you select this line or edges, and then you boss extrude to 3.125mm. Okay, alright, let's go to the next one. Alright, for the next one, boss extrude through. Alright, let's see. So for boss extrude 2, we're going to extrude the outer circle, the 11.5mm outer circle. We're going to boss extrude it. So we choose this circle, okay, and reverse the direction. When boss extrude, reverse the direction. That's why the boss extrude will be on the back. Right, you see here, the boss extrude will be on the back, and the thickness of this thing is 3.125 millimeter of thickness, both from top to bottom. This one 3.125 of thickness, the bottom one is also 3.125 millimeter. Alright, let's see. And then for boss extrude 4, you see there is another circle, the inner circle, which is 16.25 diameter. We also boss extrude it. Right, boss extrude it also to 5.75 millimeter of thickness. So the thickness of the inner circle is 5.75 millimeter of thickness. Okay, and then when we already extruded boss the inside circle, alright, as you can see here, we draw another circle. There is another circle inside of it with a diameter of so this is inside circle. The size of the inside circle, before this we draw two circle, right? But then we draw another circle inside the inner circle with diameter of 15 millimeter. This inner circle is 15 millimeter. Okay, and then we cut extrude the inner circle, to 6.25 millimeter of that. So the depth of this most inner circle is 6.25 millimeter of that. Alright, moving on. Then the last one, fillet. So as you can see, the blue point one is the edges or line that we select to fillet it. So we fillet it to 2.5 millimeter. Fillet to 2.5 millimeter. Then that's all for connector. As you can see, the result of the fillet like this. This is all the edges or line that we selected to be fillet. So this is the isometric view of it. Okay, thank you. So this is a gear pump shaft, and I will explain to you how to do it. Okay, so we begin with boss extrude 1. Let's go. So the first step is you need to draw a circle, and then by using smart dimension, this circle is a diameter of 15 millimeter. Okay, so 15 millimeter, and then go to feature and extruded boss the circle. When we boss extrude it, the length of the circle is 100 millimeter of length, so it will become like a cylinder. Alright, so this is what happened when we boss extrude it to 15 millimeter diameter of a circle, then we extrude to 100 millimeter of length. This is what will happen. So boss extrude 2. Alright, I will explain how to get this triangle here, this rectangle. So in boss extrude 2, first we must draw a center line. This center line, from this point select this point, and then to this point we draw a center line, this center line. Okay, then we draw a rectangle. This rectangle is have a length of 45 millimeter and width of 5 millimeter. And then by using smart dimension, we must firstly, before that, we must use this point, select this point, okay. Then we have to make sure that it is vertical. So there is an option for that. We make it vertical. Alright. So then we use smart dimension between the surface of this cylinder and then the rectangle. The space between it is 5.75 millimeter. 5.75 millimeter in difference between this rectangle and this cylinder. And then when we do that, alright, then we extruded past the rectangle. We extrude it to 9.5 millimeter of thickness. 9.5 millimeter of thickness. So this thing is 9.5 millimeter of thickness. Alright. Next, we go to cut extrude 1. Alright, for this. To draw cut extrude 1, first we must choose this surface. Okay, this surface. And then we select offset entities. Select offset entity and change the number to 1 millimeter. So, and then don't forget to reverse it. So this is the offset entities. If you don't reverse it, the circle will be on the outer 1 millimeter larger than this circle. But when you reverse it, it will become smaller, 1 millimeter smaller than this circle. Alright. Next, then we select line, and then we choose this circle, convert entities. So we can choose this point, we make line, this point to this point and this point, and then you select this contour, this one, as you can see, this contour, the yellow one, and we have to cut extrude to 10 millimeter. Alright, cut extrude to 10 millimeter. So the length of this thing is 10 millimeter. Alright, 10 millimeter. Okay, this thing will be gone after we cut extrude it. When we cut extrude it, alright, as you can see here, we select this point and this line. We do these two line, this line and these edges, this line and this line, and we cut, we fillet it. We fillet it to 1 millimeter of radius. So this is 1 millimeter of radius for both sides. And then we select this side, this line. We also fillet it to 5 millimeter of radius. Alright, 5 millimeter of radius. As you can see here, 5 millimeter. And then, alright, it's going to be a hard part. For the circular pattern one, when you choose circular pattern, yeah, this circular pattern, you must select fillet 2, fillet 1 and cut extruded 1. Okay, fillet 2, fillet 1 and cut extruded 1, and then select the face of circular. This is face of the circular. We're going to 360 degree with 7 equal spacing. And then don't forget to choose geometry pattern. When you, alright, like this, it will become like this, 360 degrees, 7 equal spacing. Geometry pattern, it will become like this. Okay, let's see. It will become like the 1 2 3 4 5 6 7 edges. And then for the last part is fillet. As you can see here, the rectangle that we boss extrude 9.5mm on boss extrude tool, we select all the edges and then we fillet it to 0.25mm of radius. Okay, select all the line and fillet to 0.25mm. Alright, that's all for gear pump shaft. This is the isometric view of gear pump shaft. Thank you. So this is gear pump bush with seal. Bush. This is the seal. So I will explain to you. This is quite a simple part lah. Then I will explain to you how to do it. So let's go to revolve one. Alright. Click edit sketch. Okay. So first thing that you must do is you choose center line, and then from this point you make a line. Just make a line, no matter how long, but just nice. So do center line, this line and this line. Okay, and then go to line again and select normal line, and then normal line you just copy the shape of this thing. So from this line to this line, this line to this line, just follow. And then after you do that, you use smart dimension to put the dimension of this line that you draw just now. So this line is 7.5, 6.5mm, and then this one is 5.5mm. This is 3mm, 1.5mm and 11mm. And then don't forget to choose this line and this line and make it collinear. Okay, choose this line and this line and make it collinear. Okay, after you done this thing, this basic thing, you go to feature and choose revolve both base. So when you click revolve both base, you have to select the line to be revolved as an axis. So you have to choose axis of revolution. So you have to choose this axis. So it will revolve around it, 360 degree around it. This is the axis of revolution of the push. Okay. Next, when you do that, you will get this result. Okay, this is the result. Alright, and then let's go to the seal part. Okay, for the seal part, you select this surface and then go to convert entities. When you already click the convert entities, you choose this circle. Okay, this circle revolve one, you choose this circle, and then you go to features and extruded boss to 1.5mm of thickness, so it will be like this. Okay, this thing, this yellow line is 1.5mm of thickness. So this is the seal. The seal is 1.5mm of thickness. Alright, don't forget, when you extrude boss to 1.5mm of thickness, don't forget to unmerge result. So when you do this, this will be two different part. The seal is one part and the bush is one part. So it will not be same. It will not be declared as one. So there is two part. Okay. So that's all for the bush with seal. Okay. This is the isometric view of bush with seal. Thank you. So this is a gear pump bush. Same like before, gear pump bush with seal, but this one is with no seal and a little bit different. So I will explain to you all guys how to make it. So let's go to revolve one. Alright, edit sketch. So to make this shape, just click on the line and just follow this shape. This to this line to this line, this line to this line, this point to this point, this line to this point. Just follow exactly the same. Okay. When already choose all the line here and you make it like these shapes, use smart dimension and put the dimension, which is this thing is 7.5 millimeter, 6.5 millimeter, 4.5 millimeter difference, 3 millimeter of thickness, 1.5 millimeter of thickness, 6.25 millimeter of thickness. Don't forget we use millimeter, so millimeter. Choose at the mmgs. Here choose millimeter gram per second. And then before this we use this line as normal line, right? But you can right click and select to make it we don't have here, but you can change this normal line to construction line. So make sure you change it to construction line. Then when you do that, go to features, click revolve boss base. When you do that, when you click it, the revolve will not be like this. It will be from down to up 360. So you click this line and not click this line, but you remove this line and select this axis. Before this is the axis, but we don't want it to revolve it like that. We choose this line to be revolve around it 360 degree. Okay, so when you do that, you will get a result like this. Alright, simple. And then fillet. Alright, fillet is very simple. As you can see here, this is all the selected edges or line that we fillet to 0.25 in diameter. Okay, 0.25 of radius. So that's all for gear pump bush. Very simple thing. Thank you. So this is a gear pump seal that we use between the housing and the cover of the gear pump. So I will explain to you how we made this thing. This is a very simple thing. So we go to boss extrude 1, edit sketch. So first thing that we must do is select center point straight slot and make one shape of center point straight slot, and then we use smart dimension to put the outcut. This outcut is 78 millimeter, and then the length of this middle line is 63.5 millimeter. Okay, so to do the outer line of the center point straight slot, it's really easy. Just select offset entities, and change the unit to 2.5 millimeter. Make sure the offset entities is on the outside. If you want the offset entity on the inside, just click reverse, but we want the circle to be 2.5 millimeter bigger than the inner center point straight slot. So we don't need to change anything. just click it 2.5 millimeter and it will be like this. So after that we go to features and extrude boss. Okay, so the thickness of this seal is about 2.5 millimeter of thickness. When you extrude, the thickness is 2.5 millimeter. So that's all for the seal. Alright, this is the isometric view of the seal. Thank you. So this is the last part that we have to do in gear pump. So this is the pin of the gear pump to hold the gear. Okay, so I will explain how to make this thing. It's very simple and easy. So go to Boss X1, let's edit sketch. So the first thing that you must do is select circle and then use smart dimension to change the diameter to 15 millimeter. Okay, so the circle is 15 millimeter in diameter. Okay, and then go to features, to boss extrude it, and the length of the boss extruded is 55.25 millimeter. Okay, 55.25 millimeter of length. Okay, very simple. Let's go edit sketch and then let's go to the fillet. Okay, as you can see here, we choose this point, this line and edges, these two line and edges, and we fillet it to 0.25 millimeter of radius. 0.25 millimeter of radius. So that's all that we do in this gear pumping. Very simple. This is the isometric view. So that's all for gear pump pin. Thank you. So first, this is my assembly of gear pump. So first we insert gear pump housing and then click on the eye to have view of origin. So click the same arrow so it will be not move like this. Okay, and then I change the background color to white plain. So as you can see, this is my gear pump housing. Alright, so this is the isometric view of my gear pump housing. Okay, insert component, we choose select component, we insert bush with seal. So this one is bush with seal. As you can see, there is a seal, the warna ungunya. So and then we insert another bush with no seal. Okay, the seal one is with color pink. Right, I move a little of the bush and rotate it toward the outside like this. We rotate it so it can be easy to be in the housing, and then choose mate. Okay, you have to choose this zone and this zone and then right click so it will mate together. So we have to choose side by side so it will be made together, and then choose under the seal surface, under the pink one, choose this surface, and then in the wall of the housing of the gear pump and made it together as coincidental. Okay, this is the how we do it. Okay, so same with next thing, choose mate, choose this surface, and choose the other surface that we want to be made together. So this, we choose this. Okay, and then right click. Alright, same thing with the top one, we'll choose the under the surface of the bush to be made to the wall of the housing, to the base of the housing, like that. Okay, right click. Okay, this is the isometric view of my gear pump housing.
Alright, okay, next. Alright, so we go to design library, choose design library, and then we find toolbox, and in now toolbox. So we want to insert gear pump, so go to find ISO standard. This is ISO standard, and then roll down. So you have to insert, choose power transmission and gears, and then spur gears. Select spur gears and drag out the gears. Okay, like this, drag out the gears. Okay, we need to change a little bit of the properties, so it will be same as our bush size. So alright, so we change the module to 6.5 with 10 number of teeth, pressure angle same 20, and face width we change it to 43.5. okay, change it 43.5, and then show state same. So this is the configuration name, same thing. Alright, so right click, so and then okay, show teeth square 1. So it will be inserted this gear with our shaft, with that has a shaft that has a pin. So we don't want another gear, so we click cancel. Alright, and then we alright, this gear, choose this section and make it with insert. Okay, we need to insert. Okay, make it with that, so it will be parallel or vertical into the push with seal. Okay, right, just this like this. Okay, it still can be moved, but it's not inserted properly. Then we must insert component, so we will insert shaft. Alright, this is the shaft, gear pump shaft. There is a pin on it, so move component. So we rotate from, the pin must go on the front. Alright, and then choose this section to be made to the shaft section, shaft region. Okay, so this section then made with this one, then right click. Alright, it's in the right place, but it still can be moved. The pin is not this pin is not inserted well, so choose this key, this side, and the other pin of the shaft. Do the same thing and mate them together, so it will not move after we move it. Okay, alright, and then choose this front of the gear pump, spur gear, and front of shaft, and we will be in the same line. Mate. Okay, right click. Okay, so it will be same surface. Alright, next,
Okay. Next, I think we going to insert another spur gear. Before that, okay, we forget to mate the behind this of the spur gear to the housing, so mate first. Okay, so choose select this surface, this surface, and the bush surface, so it will not move. Okay, we mate together so they don't move. Alright, right click. Alright, nice. This is the isometric view. Then we will insert another spur gear. Okay, as you can see, this is how it rotates. It did not move forward or what, it just moved on its own rotation because we already made the spur gear with the bush. Okay, next spur gear, we take another spur gear, change the module to 6.5, but we change the face width at 45 millimeter, and then square T-ways change to none, from square 1 to none. Alright, that's all. And then X, you don't want another spur gear. Okay, for this, same thing as the top spur gear, we insert component, we insert pin. Okay, this is our pin. Alright, put it there. First thing first, we put the okay, we choose mate and choose these two sides and we mate together. Alright, right click. Okay, base surface, click on it, and then we will mate with the bush seal. Okay, alright, choose, oh no, choose this. Oh, the pin we made with the inside of the bush, so it will not move. So, but don't forget also to mate the spur gear towards the bush. So move component, we drag it out again. Okay, drag it out, then move component, we move the pin also, select the surface. Okay, and choose another surface. Okay, alright, mate. Okay, nice. Okay, and then okay, you choose the shaft and you choose the pin, and then you select coincident, so it will be seams. The shaft and the pin will be same in the same point of surface. Okay, so if we, alright, and then okay, this is the ice. Okay, from view, okay, go to the tip of the spear, and then mate, change mate,
choose mechanical, and then gear, choose gear, because we want to make sure that the teeth is not collide between each other. It will collide each other, but we decide. Okay, take the meter. We choose these two face. Alright, so we will change it. The diameter 1 millimeter, and this the other one also we choose 1 millimeter. Okay. Alright, and okay, ratio 1 millimeter to 1 millimeter. Alright, so it will be balanced. Okay, right. Okay, we try to move component R, and we rotate like this. The gap is 1 millimeter, right on and the left. Okay, so moving on, let's go. We do the next part. Try to do something like this. This is, let's see what we have to do next. Okay, move component. Okay, next we try to move a little from the isometric view. Then let's see what we have to do next. So we insert component, we insert the seal. Okay, the pink one is the seal made of rubber. So same as the gear, choose this surface and then select this surface to be made together. Alright, and then choose another surface so it will be one with the housing. Let's see. Okay, choose the surface and choose the surface. Okay, it will fit just like that. So the seal is already inside the housing. Right click, settle. Right, insert component again. We put a connector. So we put a connector between shaft and the pin of the spur gear. So same thing, choose mate. Okay, choose this. No, we move backward little. Okay, choose the inside surface to be made with the shaft. Alright, inside surface. Alright, then the next we made it. Okay, then the bottom one also have to do the same. We made it. Okay, we choose mate. Alright, choose mate and then choose the surface, the pin surface and the connector surface is the inside one, and mate it together. And then we have to make sure that the connector is made to the spur gear, so we have to make it. Let's see what we're going to do here. Okay, choose the surface, move a little bit back. So choose the surface, mate, choose the surface and choose the spur gear space, so it will be the same. Okay, as you can see, it cannot be moved because it already made with the spur gear. So alright, now you move the component. Same thing, we rotate Okay, next we will insert the bearing insert component. We put the cover first lah. This is the casing or cover. Okay, alright, same thing, choose save, or don't forget to save and then you select the surface that you want to be made to the housing. Okay, let's see what we can do here. Alright, made, and then choose this surface and this surface, so it will be on the same level. It will be made. Okay, just to make sure, make with another surface. Choose the surface and the surface and mate it together, so it will be the same. Alright, so move component again, but it still can be moved. We might make sure it is fixed to the surface. Okay, choose that and choose that surface and mate together. Alright, this is the isometric view of full gear pump assembly. Okay, as you can see, it cannot be moved. Alright, next we will insert a bearing. So go to, not this, I think we have to go to another tools, go to okay, you choose SKF and choose bearing and take roller bearing and choose the needle roller bearing. Okay, choose needle roller bearing to be put with the shaft. Needle roller bearing. Alright, drag out. Okay, and then we edit the size. Okay, this is the, okay, we change it to NA 4902 size, and then display we change to detail, show roller 18. Okay, and then I think this, okay, bore body width, change all the thing to be precise. Okay, and then this is a little bit different, you change it to SI. Alright, that's all I think. So then right click. Okay, we don't want that, so X. So move component, we rotate it a little bit facing towards the housing, and then like the same thing, choose the surface to be made. Right, so we choose the inside surface and the outer surface of the bearing. Let's go. Choose made and then choose this. Okay, alright, choose the surface, so it will be intact and not move. But this still not made well, so choose that surface and that surface, so it will be fit. Okay, take mate, choose that surface and mate with that surface. Okay, easy. So okay, right click. So that's all. This is the isometric view. And then last thing, I think we must make the cover clear, so we will change the cover to clear one, the cover or casing. Oh, before that, don't forget to put go to ISO and bolt and screw and choose hex, bolt and screw socket. We find hex, bolt, screw and socket. So there is 14 hole. We need to insert a
screw, go to ISO, bolt and screw, drag down a little bit, then choose. Let's see what we're going to choose. Any hex, okay, scratch screw socket, okay, nice. And then wrong, I think, okay, hexagon socket head screw, okay, this is the right one. So choose hex socket head ISO 4762, okay, the left and bottom one, drag it out. Let's try to drag it out and put inside the cover and housing circle, put it through, okay, like this. And we change the M size, so we change to M5 size, change to M5 size. This is M8 too big, so we need to change it to smaller one. We choose M5 size. Let's go. Where is it? Oh, this, okay. M5 size, okay, it fit perfectly. Then we need to change a little bit of the thread display. Use schematic thread display. Okay, then just put it into the hole and hold it until it fixed, just like this. Hold it, okay, then right click, hold it, okay, hold, click, hold, click, hold, click, hold a little bit, hold again. It must be fitted, and then you right click, okay, left click, okay, fitted, wait a little longer, okay, right click, 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 and click again, okay, last one. Alright, settle. And then don't forget to, this is the isometric view. So we try to move component, it's already inside the casing and the housing. Next, we change the casing or cover to clear one. So this, okay, as you can see. Alright, this is the, we can see the inside, the spur gear, the connector, the seal. Okay, this is the isometric view.